I'm back to teach you more about God's true circle. Have you ever been taught the 1-inch circumference circle? I mean, surely it's important. They teach the 1-inch diameter circle. It's important. They teach the 1-inch radius circle. It's important. Why don't they teach the 1-inch circumference circle? Surely it's important. I mean, if you think about it, the diameter of the 1-inch circle is just the reflection of pi, 1 divided by pi. You would think that would be very important. It's because they got the wrong value of pi. It's an unjust scale. So let me show you what God's true 1-inch circumference circle looks like and the awesome things about it. So this is a replica of the 1-inch circumference circle. And if you're new to the channel, dividing the 360 degrees of the circle by pi, the true value of pi, is the same as dividing the equilateral triangle from a 3.6-inch hypotenuse. Because they have something in common, they're linked together. The hypotenuse of this triangle is the 60-degree portion of this circle. Notice it's 120 degrees of circumference, and this is a 120-degree back angle. But anyway, this value is 0.27 repeating in the 1-inch circumference circle. And whenever you multiply the diameter by the equilateral triangle height, it will always equal this value squared. And in this circle, it equals 0.07716049838. I know that number doesn't look familiar or anything like that. But what's awesome is this value is actually a fraction of 1/12.96. So as the circle grows from a 1-inch circumference to a 3.6-inch circumference, the 60-degree portion, which is the equilateral triangle's hypotenuse, will be 1. And that's the diameter multiplied by the equilateral triangle height as well. It'll equal 1. And for example, how this circle grows and this value works, if you would take this value and multiply it by, let's take the 30 degree for example. Whenever it's the value of 1, the circumference is equal to the square root of 38.88. So if we would take this value and multiply it by 38.88, you would see you get the answer 3, which is the square of the 60-degree portion, the hypotenuse of the equilateral triangle. And also whenever you take the diameter 2 and multiply it by the equilateral triangle height, 1 at 1.5. And a side note, rational squares mess with rational squares. Rational squares don't mess with irrational squares. So if they make rational squares on the inside, they'll make rational squares on the circumference.